Using octal as an intermediate step, that's what we're going to be looking at here. And it's intermediate to converting to base 2, base 16, and base 4. I'm only doing 2 and 16 in this example because they're very common. Binary is used by computers, so is hexadecimal. So we're going to see how this is an intermediate step. And it all works, of course, for these ones because they're all powers of 2. 2 is 2 to the power 1, 8 is 2 cubed, 16 is 2 to the 4. And when we do look at base 4, of course, that's 2 squared. So our number that we're given originally is in base 10. So let's convert that. And that's what we were doing in the previous examples. So we'll take the whole numbered part and we'll start doing repeated division by 8. So I've got 506 divided by 8. That gives me a quotient of 63. And the decimal part there is 0.25. 0.25 of 8. Of course, quarter of 8 is 2. So that would be my remainder there. And then we're going to divide the 63 by 8. And that gives me 7 as my quotient. 0.875. If I take 7 off of there, multiply that by 8, that's telling me I got a remainder of 7. And then if we divide that by 8, we get a quotient of 0, and of course the remainder is 7. So we can say that this number, remember, read backwards, is going to start 772 when we're in base 8. Now, the 0.6875, the decimal part, we're going to start by multiplying that by 8. So 0.6875, multiply that by 8, and we get 5.5. And then we're going to multiply just the decimal part. So take away the 5, multiply by 8, and we get 4.0. So it terminates there. So we've got 772.54 when we're in base 8. Now, this is how we can go to base 2 from there. We just write the numbers out, 772.54. And then we're going to convert each of those into binary. Now remember, the number columns here are going to be 1, 2, and 4. And we can only use digits 1 and 0. So 7 is 1, 1, 1. So 1, 1, 1. The next 7 then is also 1, 1, 1. 2 is going to be 0, 1, 0. So that's 0, 1, 0. Then we have the point. Now to get 5, you want a 4, no 2s and a 1. So it's 1, 0, 1. And 4 is going to be 1, 0, 0. And so we can say that the number is 1, 1, 1, 1, 1, 1, 0, 1, 0, 0.1011. We don't worry about the zeros at the back here, in base 2. So we have our answer in base 2 and we have our answer in base 8. And now we're going to go to base 16. Now base 16, we're going to need these number columns to take us up to 15. So what we're going to do is we're going to rearrange this into groups of 4, but we work outwards from the decimal point in each direction. So I've got 0, 1, 0, 1. So that's our first block of 4 up to there. So the point's here, and I'm going to go 0, 1, 0, 1. Then the next block of 4 is 1, 1, 1, 1. like so. And then I've just got 1 left, but I just put leading zeros in front of that. Then going the other way, 1 0 1 1. We only have zeros behind that, so we don't need to worry about that. So what is each block of 4 here if we work in hexadecimal? 0 0 0 1. So 0 0 0 1 is just, of course, 1. 1 1 1 1 is 8 plus 4 plus 2 plus 1 is 15. And we know that we call 15 F. So that's going to be F. Then 1 0 1 0 is 10, which we know we call A. And then we've got 1 0 1 1, and that gives us 11, which we call B. So in base 16, this number is 1FA.B.